Now we see the next problem from cosine transform. Find the Fourier cosine transform of f of x equals e power minus ax square. So whenever you have to find cosine transform, as far as possible, make use of the relation. What is the relation? You know that when f of x is even, f of alpha is same as fc of alpha. So we have to find Fourier cosine transform of e power minus ax square. So you know the transform of e power minus a square x square. I have told you should by heart this. I have shared this in formula page. I told you should remember the transform of e power minus a square x square. So what is it? 1 by root 2a e power minus alpha square by 4a square, where a is a real constant. So you should write the proof of this, and then what is asked? E power minus ax square. So replace a square by a. So f of e power minus ax square is 1 by root 2 into root a e power minus alpha square by 4a. So we are replacing a square by a here. So a is replaced by root a. So what is this? Also I told you should remember, this is given in formula page. You should by heart this formula. So 1 by root 2 root a e power minus alpha square by 4a. Then make use of the relation f of alpha is same as fc of alpha. So what is f of x here? What is f of alpha? A transform of f of x. What is fc of alpha? Cosine transform of f of x. What is f of x? E power minus ax square. So f of e power minus ax square is same as fc of e power minus ax square. So what is f of e power minus ax square? 1 by root of 2a e power minus alpha square by 4a. So this implies fc of e power minus ax square is also 1 by root of 2a e power minus alpha square by 4a. I repeat, you are asked to find the cosine transform of e power minus ax square. Whenever you have this form, make use of the formula. Write the formula first. Transform of e power minus a square x square is 1 by root 2 into 1 by a e power minus alpha square by 4a square. Then we are replacing a square by a. So for f of e power minus ax square is 1 by root 2. When you are replacing a square by a, it is understood that a is replaced by root a e power minus alpha square by 4a. So you should write the proof of this problem and then do the replacement. Then write the relation. You know that when f of x is even, f of alpha is same as fc of alpha. So that is f of x is same as fc of f of x. What is f of x here? E power minus ax square. So you know f of e power minus ax square, that is here. So which is the answer for fc of e power minus ax square? You know the answer for f of e power minus ax square, that is this expression. So if this implies fc of e power minus ax square is 1 by root of 2a e power minus alpha square by 4a. Now we have another type. Solve the integral equation. Integral 0 to infinity f of x cos alpha x dx equals e power minus alpha. So we have to solve the integral equation. Differential equation, you know what is a differential equation? An equation which contains dependent variable and derivative of dependent with respect to independent variable. Similar to that, you have integral equation. Integral equation means an equation which contains an integral. Very simple. So integral, so you have to solve this integral equation. That means what? Transform is used to solve even integrals. Transform is used to solve even definite integrals. So if you solve the integral equation means you have to find the unknown function f of x. See, in previous problem you are given f of x. You are asked to find the transform. You are asked to find the cosine transform. But here you don't know f of x. You can find f of x, you can find the given function using cosine transform. So start with the definition. Cosine transform of f of x is defined as root of 2 by pi integral 0 to infinity f of x cos of alpha x dx. So then what is given? Integral 0 to infinity f of x cos alpha x dx equals e power minus alpha. So whatever is given, take it as 1. always start the problem with the definition of that formula. Then when you are given an integral equation, take that equation as 1. Then the next step, you multiply both sides by root of 2 by pi. Next step is to multiply both sides by root of 2 by pi. The reason behind doing this is to get Fourier cosine transform. The reason for multiplying the given equation by root of 2 by pi is to get Fourier cosine transform. So root of 2 by pi integral 0 to infinity f of x cos of alpha x dx equals root of 2 by pi e power minus alpha. Take it as 2. Now you have to find f of x. I told you solving integral equation means you have to find f of x. Whenever you have to find the function, you have to make use of inverse transform. So write the definition of inverse cosine transform, that is f of x equals root of 2 by pi integral alpha equals 0 to infinity fc of alpha cos of alpha x d alpha. So what is fc of alpha? Root of 2 by pi e power minus alpha. This is what is the left side. The left side is cosine transform. So what is it? Root of 2 by pi e power minus alpha. That is what substituted here. fc of alpha is same as root of 2 by pi e power minus alpha. So root of 2 by pi integral alpha equals 0 to infinity root of 2 by pi e power minus alpha cos of alpha x d alpha. I repeat, we have written the definition of inverse cosine transform. And what is fc of alpha? You see equation 2. This is fc of alpha. Left side is fc of alpha. What is it? Root of 2 by pi e power minus alpha. So that is substituted here. In the next step, root of 2 by pi whole square is 2 by pi integral alpha equals 0 to infinity e power minus alpha cos alpha x d alpha. Now make use of the formula e power ax cos bx. A is minus 1, b is x, a is minus 1, b is x. So e power minus alpha by minus 1 whole square plus x square a cos bx plus b sin bx. So a is minus 1, b is x. So minus 1 cos alpha x plus x into sin alpha x, where alpha varies from 0 to infinity. What is integral e power x cos bx? E power ax by a square plus b square a cos bx plus b sin bx. So in place of a you have minus 1, in place of b you have x. Alpha is a variable, minus 1 and x are constants. So e power minus alpha by a square, that is minus 1 whole square, plus b square, that is x square, into a cos bx. So minus 1 cos alpha x plus b sin bx, that is x into sin alpha x. Alpha varies from 0 to infinity. When alpha takes the upper limit, e power minus infinity is 0. So whatever be the bracket term, the upper limit is going to be 0, minus when alpha takes a lower limit, e power 0 into minus 1. When alpha takes upper limit infinity, e power minus infinity into something is 0, minus when alpha takes a lower limit 0, e power 0 into cos 0 is 1, so minus 1. So on simplification, 2 by pi 1 by 1 plus x square. So this is the function. So you have the integral equation. You are able to get back the function f of x using cosine transform. So one of the applications of transform is to solve the definite integrals. Without knowing the function, you can get the function using the transform. So it is applicable for any transform or cosine transform or sine transform. You can use any transform to solve integral equation. So depending on the equation, if you have cos alpha x, make use of cosine transform. If you have sin alpha x, make use of sine transform. If you have e power I alpha x, make use of transform. I repeat, whenever you have to solve integral equation, you have to make use of inverse definition. If you have cos alpha x, start with cosine transform. If you have sin alpha x, make use of sine transform. If you have e power I alpha x, make use of transform. So we will be doing a problem from sine transform also. I will discuss that. We will be solving integral equations using sine transform also. Now we have another problem of this type. Solve the integral equation integral 0 to infinity f of x cos of alpha x dx equals 1 minus alpha. Alpha is in the closed interval 0 1, 0 when alpha greater than 1, and you are asked to deduce this integral. So whenever you have solved the integral equation, if the question is to solve the integral equation, it means you have to find f of x. I repeat, if the question is to solve the integral equation, it means you have to find f of x. So start and you see the function. What is the kernel here? Cos alpha x. So start with the definition of cosine transform. What is the kernel function? Cos alpha x. So you start with cosine transform. If you are given sin alpha x, write the formula for sine transform. So here you have cos alpha x. I have written the formula for cosine transform, that is fc of alpha. How it is defined? Root of 2 by pi integral alpha equals 0 to infinity f of x cos of alpha x dx. Then the next step, see, in the previous problem you have only e power minus alpha. You have only one expression in the right side. In previous problem you have only one expression in the right side, but here you have in two subintervals. Right side is expressed in two subintervals. Whenever you have two or three subintervals, two or more subintervals, take it as phi of alpha. Take the right side as phi of alpha. Why I am taking it as phi of alpha? You see the integral. I told you definite integrals are always solutions of constants. So which is a constant? Alpha. X is a variable, alpha is a constant. So that is why we are taking right side as phi of alpha. I repeat, whenever you have the solving the integral equation, if the right side is in two or more subintervals, take the right side as function of the constant. So you see the left side, x is a variable, alpha is a constant. That is why we are defining right side as phi of alpha. I am repeating, definite integrals are always solutions of constants. So that's why this is taken as phi of alpha. So let phi of alpha be the right side, that is 1 minus alpha, 0 less than or equal to alpha less than or equal to 1, 0 when alpha greater than 1. So what is the left side now? What is 1 now? What is equation 1? Integral 0 to infinity f of x cos alpha x dx equals, this we have taken it as phi of alpha. That's what I have written here. So right side is phi of alpha. So left side is equal to phi of alpha. So I have taken, we have rewritten 1. We have rewritten 1 as left side equals phi of alpha. Then as you did for the previous problem, multiply both sides by root of 2 by pi. As we did for the previous problem, we multiply both sides by root of 2 by pi. The reason for doing this is to get Fourier cosine transform. The reason for doing this is to get Fourier cosine transform. So root of 2 by pi integral is x equals 0 to infinity f of x cos alpha x dx equals root of 2 by pi phi of alpha. Then what is left side now? It is a definition of Fourier cosine transform or FC of alpha. So left side is FC of alpha equals root of 2 by pi phi of alpha. As we are proceeding in the same way as we did for previous problem. Now what is the next thing? What is our objective? Our objective is to find f of x. We have to find f of x. Whenever you have to find the function, original function f of x, you should do the inverse. So write the definition of inverse transform. F of x equals root of 2 by pi integral alpha equals 0 to infinity fc of alpha cos alpha x d alpha. What is fc of alpha? Root of 2 by pi phi of alpha. What is fc of alpha? Root of 2 by pi pi of alpha. So root of 2 by pi whole square, that is 2 by pi. So f of x equals 2 by pi integral alpha equals 0 to infinity phi of alpha cos alpha x d alpha. F of x equals 2 by pi integral alpha equals 0 to infinity phi of alpha cos alpha x d alpha. So we have got the function. Now what is phi of alpha? How phi of alpha is defined? 1 minus alpha from 0 to 1. What is phi of alpha? 1 minus alpha when alpha varies from 0 to 1 and 0 when alpha is greater than 1. How phi of alpha is defined? 1 minus alpha when alpha varies from 0 to 1, 0 when alpha is greater than 1. So this integral is split into two. So the first integral, alpha equals 0 to 1, 1 minus alpha cos of alpha x d alpha, and the second integral, alpha equals 1 to infinity 0 into cos alpha x d alpha, which is 0. The second integral is 0. So the first integral, so you have to do integration. You can do Bernoulli's integration. 1 minus alpha, what is integral cos alpha x? Sin alpha x by x. Alpha is a variable, x is a constant. You should be careful. Alpha is a variable, x is a constant. So 1 minus alpha, what is integral cos alpha x with respect to alpha? Sin alpha x by x, minus what is u dash, what is the derivative of 1 minus alpha? Minus 1, into integral of sin alpha x by x with respect to alpha. So minus cos alpha x by x square. Alpha varies from 0 to 1. I repeat, the second integral is 0. First integral, we are using Bernoulli's rule. U is 1 minus alpha, v is the cosine function, u v1, 1 minus alpha into integral of cos with respect to alpha. So sin alpha x by x minus u dash, derivative of 1 minus alpha is minus 1. Integral of sin alpha x by x is minus cos alpha x by x square. Alpha varies from 0 to 1. So when you are doing the integration, you should be careful. In inverse, alpha is a variable, x is a constant. Whatever be the transform, in inverse always alpha is a variable and x is a constant. So now when alpha takes the upper limit 1, 1 minus 1 is 0. When alpha takes a lower limit 0, sin 0 is 0. I repeat, when alpha takes the upper limit 1, 1 minus 1 is 0. When alpha takes a lower limit 0, sin 0 is 0. So the first term is 0 for both the limits. Second term, minus 1 by x square. When alpha takes upper limit 1, cos x. When alpha takes a lower limit 0, cos 0, 1. So minus of minus, so if you take minus inside, you will get f of x as 2 by pi x square 1 minus cos x. So if you take minus inside, the function is, by solving the integral equation, what do we get? F of x equals 2 by pi x square 1 minus cos x. So we have solved the integral equation and we have got f of x. Now what is asked? We are asked to deduce this result. So now we are asked to deduce the result. Now get back to the definition of inverse cosine transform. I told you, whenever you are out to deduce something, evaluate or show that or prove that, start with the definition of inverse transform. So since we talk about cosine transform, we use inverse cosine transform. What is the definition? F of x equals root of 2 by pi integral alpha equals 0 to infinity FC of alpha cos alpha x d alpha. I think we have covered this. Okay, now we have got f of x as 2 by pi into what did we get? F of x, we have got it as 2 by pi x square into 1 minus cos x. Yes, 2 by pi x square into 1 minus cos x, we have got f of x, and we are asked to deduce that. We are asked to deduce these two. Okay, now what is given? Integral 0 to infinity. This is the integral equation. You are asked to deduce the result. So integral 0 to infinity f of x cos alpha x dx is given to be 1 minus alpha when alpha belongs to the closed interval 0 1, 0 when alpha greater than 1, and we have taken this as phi of alpha. Now we have got f of x. What is f of x? 2 by pi x square 1 minus cos x into cos alpha x dx equals phi of alpha. I repeat, see, we have solved the integral equation and we have got f of x. Now what is left for us? We have to deduce these two results. So we are substituting for f of x in 1. How we are going to get these two? We are going to substitute for f of x in 1. So what is 1? 1 is this equation. What is f of x? 1 2 by pi x square into 1 minus cos x. What is f of x here? 2 times 1 minus cos x by pi x square into cos alpha x dx equals pi of alpha. Now x is a variable, you have x as a variable and alpha as the constant. You see the integral, the integration with respect to x. So x is a variable and alpha is a constant. So see how we can, what we should get, keep an eye on the question. We should get 1 minus cos alpha by 1 minus cos x by x square. We should get 1 minus cos x by x square. So we should get 1 minus cos x by x square. So you should get cos alpha x as 1. So how we can get cos alpha x as 1? X is a variable. I can give value only for the constant alpha. So I am taking alpha as 0. See, I need integral 1 minus cos x by x square. So I should eliminate cos alpha x. That means cos alpha x should be 1. So how to make cos alpha x as 1? By giving value to the parameter alpha. So if you take alpha as 0, cos 0 is 1 and right side phi of 0. What is phi of 0? At alpha equals 0, 1 minus 0 is 1. What is phi of 0? Phi of alpha is 1 minus alpha. When alpha is 0, 1 minus 0 is 1. So phi of 0 is 1. Then cross multiply integral x equals 0 to infinity 1 minus cos x by x square dx is pi by 2. What is 1 minus cos x? We have to get one more result. What is that? Sin square t by t square. So what is 1 minus cos x? 2 sin square x by 2. What is 1 minus cos theta? 2 sin square theta by 2. So that's what we have done here. Then keep an eye on the question. You should get this result. Sin integral sin square t by t square dt. So take t as x by 2. dt is half dx or dx is 2 dt. So substitute that integral t equals 0 to infinity 2 sin square t dx is 2 dt, x is 2t, so 2t whole square equals pi by 2. So x by 2 is taken as t, dx is 2 dt, denominator x is 2t, the whole x square is 2t the whole square, t also varies from 0 to infinity. So the both numerator and denominator you have 4. So this simplifies to integral t equals 0 to infinity sin square t by t square dt equals pi by 2. So this completes the problems for this class. So you practice this. As you listen, you write every step in the notebook and then try to understand. You listen to the video, you see the notes and write each and every step in the notebook. That way you will understand very well. Listening alone will not help. Still, if you have doubts, you can call me for doubts.